In this session, as we have discussed previously, the reactors, the types of reactors, ideal reactors, non-ideal reactors. Now we need to set what is the residence time distribution. So each and every reactors needs some time for complete mixing and for complete reactions. So that comes under the resident time distribution. That is how much time we need to give for proper reaction taking place or not. So the factors that makes the contact or flow pattern are the RTD. 1. The residence time distribution of the fluid flowing through the vessel, the state of aggregation of fluid, and the earliness and the lateness of the fluid mixing in the vessel, that is residence time distribution function. The time it takes a molecule to pass through the reactor is called the resident time. That is, the time it takes the molecule to pass through the reactors is called resident time. It clears that the fluid taking different routes through the different reactors may take different length. So there is a distribution of resident time of the fluid within the reactors. So that is called residence time distribution function. So the exit age distribution, that is E, or the resident time distribution RTD, is the distribution of time that enter of the fluid and out of the fluid from the reactors. In ideal PFR, all the molecules within the reactor have the same length of time. In ideal batch reactors, all the molecules within the reactor have the same length of time. The ideal PFR and BR are the only, that is batch reactor, in which the fluid elements in the reactors have the same residence time. So in all the other reactors, various molecules spend different time inside the reactor. Example, mixed flow reactors. So each and every reactor have their own residence time of distribution. So how to measure? How to measure this resident time distribution is experimentally done using an inert chemical called tracer, that is dyes and radioactive materials. This experiment will be performed in your lab for a better understanding. The characteristics of chemical tracer: first, it should be a non-reactive, it should be completely soluble in the system fluid, it should be easily detachable. The physical properties of the tracer should be similar to the system. It should not absorb on the walls or other surface in the vessel. So the various methods are pulse input, step input, periodic input, and random input. So these are the various methods which is used to measure the RTD measurement. The diagrammatic representation have been seen here, where you are using the pulse input, the step input, the periodic input, and random input. The pulse input is known for the tracer is suddenly injected in one shot into the fluid in a very short interval of time. The tracer concentration at the extreme is measured, and that as a function of time. The RTD analysis of this concentration is tabulated and a curve is being drawn. The amount of tracer material leaving the vessel is obtained by the material balance. The next method is E curve and C curve. So all these things will be experimentally done in the lab, and based on the data you will be taken and drawing the graph. From there you will be estimating that what is the resident time distribution. So let me see with the F curve first for your better understanding. Prepare the tracer first, collect the outset sample, that is begin sampling the outlet, analyze the sample. The F curve is a cumulative distributive function, and plot the F curve. Determine the MRTD, that is the curve that can be used for finding out the resident time distribution, and interpret the results. So all these things we will have a clear understanding during your lab session, where you will be doing this experiment and taking the reading and tabulate the reading and draw the graph and find out the curve. Based on the curve, what will be your resident time distribution of that particular reactors. So these are the examples, the problems we will be running through in the class session. So in short, the calculation of the resident time distribution is very, very essential to find out the performance of each reactors. So once you know the resident time distribution only, you can allow the reaction to proceed. Thank you.